Hi everyone, I'm Abby Brown. It's such a pretty day to be outside and enjoy this big, beautiful world. Did you know that everything we see, everything we touch, even this water, even me, everything is made up of matter? Matter is anything that takes up space. Chemistry examines matter. Like, what is matter made of? How does matter change? And since matter is everywhere, chemistry has limitless possibilities. Go beyond with Iowa PBS and the Science Center of Iowa as we discover chemistry.
So what's really great about this is basically I've created
another finger and you tap on your fingernail.
We made something new. We made carbon dioxide.
I am so excited because we are about to go on an awesome science adventure. My friend Allison from the Science Center of Iowa is going to show us some awesome experiments that will open our eyes to the fascinating world of chemistry. Take it away, Allison.
Hi friends. Have you ever wondered why the grass is wet in the morning, or why your ice cream cone melts when it's a really hot day outside? Or even my favorite, how cookies become so delicious when they're made out of so many different individual items? Well, that's because of something called chemistry. Chemistry is the study of matter, and matter is all around us. And today, we're gonna explore chemistry together and learn a little bit more. I mentioned that chemistry is the study of matter. Matter comes in all different shapes and sizes. In fact, it's anything that takes up space. So, like the cart here in front of me, that's a solid. It's hard, you can't go through it very easily. We also have liquids, like water that you've experienced before, or even something that's around you that you don't even often think about, gases in the air. So if you take a deep breath in, and you blow it out, you can feel that matter moving through your lungs and back out into the air around you. So now that we understand that matter comes in three basic states, that solid, that liquid, and that gas, we need to understand how it changes between those different states. Matter is made of these itty-bitty little things called atoms. And atoms are part of this really special table called the periodic table of elements. Each of these squares and letters represent a very special type of atom. And these atoms make up everything in the universe. And when you put certain types of atoms together, you get different types of materials. So for example, if you take two hydrogen atoms and an oxygen atom, you make something called water. So you've had water around you all the time. So we have water. So you can see hydrogen, hydrogen, oxygen, water. Now, we're gonna explore what happens to molecules when you give them more energy. So here, we're gonna pretend that my ping pong ball is a molecule, okay? And inside here, I have a variety of molecules, and right now they don't have a lot of energy. I want you to observe with your eyes and notice what happens as I turn on my fan and I give those ping pong balls more energy. You ready? Here we go. Sometimes it takes a little bit of time to get an experiment up and going. So here, those ping pong balls are moving around just a little bit more, and then they get more and more and more energy. And as they go from being really close together, those molecules are moving, as we can think of it, from being really close together as a solid to when they were moving around a little bit more as a liquid, and then when they were bouncing around a lot and had a lot of space and a lot of energy together as a gas. Because energy comes in different types, just like heat. So if you ever think of like yourself on a cold day, Lots of times you'll kind of come in really close and you want to be close together. Your molecules do the same thing. Molecules that are cold, they want to be close together. They don't have a lot of energy. And then as they get more and more energy, they like to move around and spread out. So we're going to show you a couple of experiments today with physical reactions. That's what it's called when you change between a solid, a liquid, and a gas. So before we start, we always want to do safety first. I'm going to put on my goggles to protect my eyes. I'm going to put on my gloves to protect my hands. And if you're ever doing experiments at home, you need to do the same thing. You need to protect yourself. You need to protect your eyes, you need to protect your hands, you need to protect your area in which you're going to do experiments, and most importantly, you need to check with an adult because they'll make sure that what you're using is safe for you to do. So back to physical reactions. Remember, we are thinking about molecules. And for the first one, we're going to go back to water, that 2 hydrogens and that 1 oxygen. And in its solid form, it is ice. You've had ice in your drinks before, maybe in your water, just to make it a little bit cooler. Whoops, it's very slippery because it's already transitioning. Ice at 32 degrees is a solid, so that water, those molecules are really close together. By being in this room, we're adding more heat and more energy. And so those molecules are starting to warm up and take up a little bit more space, and so it's starting to melt. It's going from a solid to a liquid. Then if we left this ice cube out here long enough and it turned all the way to water as it's liquid, and then it turned, if we added more heat and gave it more time, all this water here would actually turn into water vapor, which is the gas form of water. So we are thinking about how things gain energy and they change shape. And you can do this in reverse too. You can take away energy and change shape. So you can go from water vapor and make that cooler and take away that energy and go down to water liquid. So like in the mornings when you see dew on the grass, that is going from that water vapor to that water liquid. And if you put that water liquid in the freezer, you get to solid, that ice cube. So those are things that we can think about. Now, different types of matter react differently to different amounts of energy. So remember, we're thinking of energy as being heat. And here I have another solid, but it's even colder than my ice. This is 109 degrees below zero. This is dry ice. Dry ice is actually made out of different molecules. These molecules are made out of carbon dioxide. So we have 1 carbon atom and 2 oxygen atoms. And in its solid form, it's really, really cold. Those molecules are really close together. But as we bring it out into this room, which is a lot warmer than that dry ice, those molecules heat up so rapidly that they just skip the liquid form and they go straight to the gas. So that's a process called sublimation. It's a phase change. So we're going from one phase of matter, a solid, to a liquid because we're giving it a lot of energy. It's happening really, really fast, and we're skipping that liquid altogether. So those are some types of reactions that we like to call physical reactions. In chemistry, we study physical reactions, but we also study chemical reactions. In chemical reactions, you can kind of think of like a math problem. You have these ingredients that go together, so think about like the number 1 and the number 2, and when you add them together, you get the number 3, and that is what a chemical reaction is. So today we're going to look at a couple of chemical reactions and some safety tips to think about if you do decide to do some kitchen chemistry experiments at home. This first one uses a solid, this little white powder here called baking soda. And even though it doesn't look very solid to our eyes, it's solid because each of those little grains of powder are solid themselves. So solids don't even have to be big. They can be really, really tiny too. Now, I've gone ahead and put my baking soda in this super scientific balloon. And in this balloon, we have just that solid and a little bit of air from the air around us. Then, in my flask, I have a chemical that you're probably familiar with called vinegar. And vinegar, it's really stinky. It looks like water, but it's not water. And in order to do our experiment here, I'm gonna give it a little bit of color, because color is always fun. So we're gonna give it a little bit more color, swirl it around. So now we just have blue vinegar. I'm gonna take my baking soda and control the experiment by putting the balloon over the top of the flask. And then we're gonna combine them together. Now scientists, one of the most important skills that they have is observation. And they use all different types of their senses to observe. Sometimes they observe by what they hear, sometimes they observe by what they see, sometimes they observe by what they smell. Remember that vinegar and how it's kind of smelly? And then we can also observe, we don't often want to do taste, but we can also observe by touch or like a temperature change. So I want you to be thinking about what you could observe as I do this experiment. Remember, we have a liquid, we have a solid, and what could we be making as we put those two together? So, ready? Here we go. So what do you notice? What do you notice happening? Do you see the fizzing and the bubbling? You might not be able to hear it, but it definitely is making a sound. I can tell you that my container has gotten a little bit colder, and probably the biggest one that you've noticed already is that my balloon has blown up. And that's because when we added the vinegar and the baking soda together, remember, think of that as a math problem, we made something new. We made carbon dioxide. Do you remember carbon dioxide from earlier? That CO2, that one carbon atom and those two oxygen atoms, that is the product when you combine vinegar and baking soda together. So we did what's called a three-state reaction. Remember, we had that solid, that baking soda powder. We had the liquid, we had the vinegar, and then we made a gas, that carbon dioxide. So I have one more experiment to do that's one of my favorites. But before we do that, I want to talk a little bit about safety. One of the things about chemistry and matter is often things look the same but are different. And so observation isn't always something we can rely on only by our eyes. So in this flask, this clear liquid's water. In this flask, this clear liquid is vinegar. Would you want to drink vinegar straight? No, it wouldn't taste very good. And in this flask, even though it looks the same, this is a completely different chemical called hydrogen peroxide. And this is something that doctors use and nurses use at like the doctor's office, helps clean up things and keep them nice and healthy. But the difference between water and hydrogen peroxide is you definitely don't want to drink hydrogen peroxide, just like you don't want to drink vinegar. So we have to be really, really careful in understanding what we're putting together beforehand and knowing that it's going to have a safe result afterwards. So in our final experiment, we are going to use that hydrogen peroxide. Now, hydrogen peroxide is pretty close to water on a molecular level, or all those little molecules. So that molecule is made up of 2 hydrogen and 2 oxygen. It has an extra oxygen. And over time, that hydrogen and that oxygen break down apart from each other into a liquid that we're familiar with, that water, that H2O, and that gas, oxygen, that we're familiar with, which we need to breathe on a daily basis. So here in my flask, I have that hydrogen peroxide, and remember, I'm wearing gloves to protect my hands. And in order to make our experiment just a little bit more fun, I'm gonna add a whole bunch of food coloring here. And we're gonna swirl it around and get it really well mixed up. So we have our hydrogen peroxide in here. Now, in order for us to see what's happening a little bit better, I'm gonna add some liquid dish soap. And I want you to think about what happens when you put a gas in liquid dish soap. Maybe you've blown bubbles before. We're gonna stir that together, mix that up really well again. Now, that chemical reaction of breaking down the hydrogen peroxide into water and oxygen usually takes a long time. But scientists have this special tool called a catalyst, which allows us to speed up reactions. So we want to be able to see this move faster. We want to see that happen faster. In this case, this is a very common catalyst. I have yeast that have been growing here for just a little bit. And a catalyst, this yeast catalyst allows that reaction to just happen on top of it. It's kind of like the molecules are having a dance and breaking apart, but it doesn't actually change the yeast. So we are gonna see that chemical reaction of that hydrogen peroxide breaking down, making new products as we go. Are you ready? Here we go. In 3, 2, 1. And sometimes reactions take a little bit of time to get going. And there we go. You can see and observe with your eyes. We have all this wonderful foam coming out. So it's just really dense bubbles, lots and lots of bubbles together that are filled up with that oxygen gas that is coming from the breaking down of the hydrogen peroxide to turn into that water and the gas. And we like to call this elephant toothpaste because it makes a lot of it, and you can imagine like an elephant brushing its teeth. So, just to recap, today we talked a lot about matter and how matter is everything around us. It comes in different states and shapes, so solids, liquids, and gases. And there's different types of reactions that we experience around us when we're doing chemistry. Those physical reactions where we have matter that's just changing shape, and those chemical reactions where we're making something completely new. I want you to remember that to do your science experiments safely, you can go to sciowa.org to go beyond with SCI and do kitchen chemistry experiments at home. Thanks a bunch, and it's been great learning with you today.
Experiments like those make chemistry so much easier to understand and pretty exciting too. That was amazing, Allison. Thank you everyone for going beyond with Iowa PBS and the Science Center of Iowa. And always remember to ask questions and wonder. That's what science is all about.